This is the concept of position and displacement. In this video, we are going to explain the difference between position and displacement versus distance, which is an important distinction in physics, how to calculate the two, and how to graph them.
First, we're going to explain the difference in how you calculate the two on a number line. Distance is the measurement of how far something is moved, regardless of the direction. So let's say we have a mini car at position 2. The car moves 5 meters in the negative direction, to negative 3. So 5 meters is our distance. Then it moves back 4 meters in the positive direction, so its position is now 1. In measuring distance, the direction of movement does not matter. So if it originally moved 5 meters, then moved another 4, the total distance traveled is 9. Distance is a scalar measurement because it only measures magnitude, not direction.
Displacement, on the other hand, is a vector because it measures distance and direction. To measure displacement, we simply calculate how far away and in what direction the final position is from the starting point. So even though the car moved 9 total meters, it still ends up only 1 negative unit from its starting point. So the displacement is -1. You can also calculate the displacement by adding all of the displacements along the way. The car initially moves 5 meters in the negative direction, so its displacement is -5 meters. Then it moves 4 meters in the positive direction, so +4 is its displacement. And its total displacement is the sum of those two, which is -1 meters.
So now let's add the component of time. Let's say the car starts at position 0 and goes 3 meters to the right in 1 second. Now its position is 3, and its displacement is +3 meters, along with its distance. Now the car stops for 2 seconds, so it remains at position 3, and now 3 seconds have passed. Then it quickly backs up and goes backwards 6 spaces in 1 second. Now its position is -3 meters, along with its displacement, because it started at 0. But its distance is actually 9 meters, because that's how far it traveled total. Then it continues backing up, but a little bit slower. It goes backwards 2 more meters in 4 seconds, so at 8 seconds it is at position -5.
This graph could tell you the whole story of the displacement of the car. Why does this graph indicate displacement? Because the y-axis is position, not distance. The first section here is going up fairly steeply, meaning that the car is traveling quickly in the positive direction. And the flat section here shows that the car is not moving at all. And the very steep downward section shows that the car is moving very quickly in the negative direction. Then this next, flatter section shows that it slowed down but kept moving negatively.
So why does the slope of the graph indicate velocity? The slope of the graph is rise over run, which is, on this graph, change in position over change in time. Change in position is the same thing as displacement, and displacement over time is the same thing as velocity. So we can calculate the velocity of the car in each section of the graph using the graph's slope. In the first section, the car travels 3 meters in 1 second, so it goes 3 meters per second. In the second section, the car goes 0 meters in 2 seconds, so it goes 0 meters per second. And in the third section, the car goes 6 meters negatively in 1 second, so it goes -6 meters per second. Then it goes 2 meters negatively in 4 seconds, so its velocity is -0.5 meters per second. So to calculate the average velocity, you just simply do the total displacement over the total time. What do you think the average velocity is? Pause the video and try it on your own, and then we will explain it next.
Because the car ends up at -5 meters and started at 0 meters, its displacement is -5 meters, and it took 8 seconds in total, so on average it went about -0.63 meters per second. If we were to graph the distance, on the other hand, we would have a simple distance and time graph. The graph would never go downwards because you cannot go a negative distance. The direction is not taken into account in this graph. In addition, because there is no position indicated in this graph, only distance, you can find the speed but not the velocity of the car. It is easily visible as the slope of the line, or distance over time. Unlike the velocity, all of the speeds will be positive because the distance, the numerator, is always positive, unlike the position.
To summarize, displacement is a vector and measures both distance and direction, whereas distance only measures how far something goes. You can calculate displacement by finding the difference between the final position and initial position, and velocity by calculating displacement over time.